Okay, normally when you see the word equation, you're looking for something that is balanced. So a lot of times people will have a demonstration of a balance scale and it's got equal weight on the left side, equal weight on the right side. So it's hardly ever a time at which they say, give me a value of x that makes this false. But making an equation false means that I am replacing this x with some number that's going to make the left side not be equal to the right side. So let's just say I randomly pick the number 5 to be in place of the x. An x right beside a number 4 means the operation I would do would be multiplication because 4 is a coefficient to the x. So then I would add 1. So if I do the order of operations, I do 4 times 5 is 20. 20 plus 1 is 21. So I have 21 on the left, but I have nothing to replace here other than bring down the 3 because this doesn't have the variable x. Well, this is not true. So it was very easy for me to find a value of x that made this equation false. I could have went back and plugged in some other random number. I could have plugged in the number 0. So 4 times 0 plus 1 would give you 1. 1 doesn't equal 3. That's false. The hard part is when they change it and they're asking you to find a number that would make this equation become true. That's a little bit more tricky. So to find a number that would make it be true, if you're very skilled at solving equations, you could solve this two-step equation. At this point, some of you may just want to guess and check. Plug in a number in your head, see if that works. So to save time though, we're going to work this out. Here's the 4, the coefficient. It's attached by multiplication. The 1 is a constant. It's attached by addition. So when you're doing an equation, you always try to get rid of the constant that stands alone first. So to do that, you do the inverse operation of addition. So the inverse operation of addition is subtraction. So that gives me 2. And I like to draw a line right here because when I do a step, I like to rewrite what I have. I have a 2. This becomes a neutral pair, and then I have a 4x. But never, ever, ever forget to bring down this equal sign because that separates your left from your right. Now I have a coefficient of 4. If this is attached by multiplication, the inverse of multiplication is division. So I'm going to get rid of the 4 by dividing by 4. So one type of number that when students are using the guess and check, they always pick easy numbers like 0, 1, 2, 3. But you have to understand that sometimes answers turn out to be fractions, sometimes they're decimals, and sometimes they're negative decimals. So you have to really get good at solving equations because one number that might balance equation might be negative 7.875. And that's really hard to guess and check, which is why we teach you how to solve it directly. So in this case, 1/2 works. If you take half of 4, that gives you 2, and 2 plus 1 makes 3. That's the only number that would make that equation be perfectly balanced. So in this set, what you're asked to do is you're asked to take these set of equations and make 3 columns. One column, you're going to put it's always true. Now, if you put the equation in the column that is always true, that means it doesn't matter what number you choose to plug in, it's always going to be true. So you're going to be cutting out these cards and placing them where you think they need to be. If they're always true, put them in the always true column. If you say that one of these equations is sometimes true. Sometimes true was like the one that we just did, 4x plus 1 equals 3. The only number that would have worked would be 1/2. You plug in anything else. So I'm going to ask you, if you put one of these equations underneath the sometimes true, I want you to solve and tell me what is that one single x that you could plug in. The third column, you're going to list the equation underneath the column that's called never true. That means it doesn't matter if you sit here for a whole week plugging in a number, you are never, ever, ever going to find a value of x that will make the equation true. So that would mean either the left side is always going to be bigger than the right side or vice versa. But they're never ever going to end up being equal. So that's how you do this MFAL right here. You make 3 columns, always true, sometimes true, never true. Work with a partner and decide where would these equations fall. You can solve them, you can do guess and check, but if you put it under sometimes true, I actually want to know what is the value of x that would make that equation true.